Good morning, everybody. Good morning. Good morning. Good morning. Just quickly checking live audiences. Crazy physics learners, can those of you on those that are on the can you hear me? Just quickly confirm for me that you can hear me. Thank you, Kate. Good morning, everybody. Just quickly checking on our live YouTube live audience right now, just to make sure that we are on. Good morning. I hope you have your cup of coffee. All right, just a moment. Just a moment. If you are live on our YouTube page, just a moment. Just want to make sure things are very clear for you. And having a bit of a system glitch here, but we'll be with you in just a moment. Those that are watching us live on YouTube, I just want to make sure that you are connected. We do not really have the luxury of time, but we will get you. All right. I think we are good. Awesome. Awesome. All right. Um, oh, great. Thank you. I'm just seeing your messages now coming through. Thank you, Tato. And thank you, everyone. If you can just let us know where you are also watching from, we will appreciate it. Thank you, Spogasizwane. If you can let us know where you're watching from, it will be of great delight to us. Just tell us your location, your school, probably. Okay. So please, we would like to hear from. Just drop us a chat, and we'll take it from there. It's our first morning. Okay, 60 minutes maths and science. Cockcrow with Crazy Physics, live streaming on YouTube. All right, first of its kind to wake you up early in the morning. And we thank you for just catching up with us. Make sure you subscribe, tell others, share, quickly call your friends and wake them up. Tell them to just run to their phones and let's get some maths sorted. All right, it is important as we prepare for exams. Remember, we only have 60 minutes. We're going to look at calculus today, day one, and we're going to start with basic things that everyone knows. Guys, I'm only going to do one question on this. I don't want any one of us to lose this marks. Okay, no one is allowed to throw these marks away. So please just follow through. Like I said, I'm only going to do one of this. And yep, we will take it from here and move to the next dimension of questions. And why am I doing this? I'm doing this just to clarify notation errors that we make all the time from experience. Now, the examiner has given you f of x equals to x squared minus 3x. First, have your anticipated answer. What is our anticipated answer? That f prime of x should therefore be equal to 2x minus 3. If you are not getting this at the end, then you can go back and check where you've made mistakes. It's very important to start with this anticipated answer. You find some of us getting 4, some of us getting 3 by simple errors. Okay, what is our formula? Our formula is f prime of x. Please also, how you write the formula is important. Limit as h approaches 0. Please, these things are together. Don't separate them. F of x plus h minus f of x over h. Please don't write them wide and walled apart. Don't. They are together. So it's important, like I said, one of the things I want to clear this morning is the errors that we make when we write all of these things. Now, for me, thank you. All right, the Sian from Durban, lovely. Good morning. Secondary school, lovely. Thank you. Guys, we would love to hear from everyone where you are watching from. Thank you. Okay, now you would notice that I need to get f of x plus h. Let's go find it. We know that our f of x is equal to x squared minus 3x. Now, what is f of x plus h? Anywhere we see x, we put in x plus h. So it's going to be x plus h. It's quite easy this way. And watch this presentation. Makes math very easy. We expand that. X squared plus 2xh plus h squared minus 3x minus 3h. You are done with that notation. Life becomes very easy and simple. Now we bring in back our formula. F prime of x equals to limit. Please keep writing that as h approaches what? 0. Now, what is your f of x plus h? That has been simplified. There's a mark there. You bring that in now. X squared plus 2xh plus h squared minus 3x minus 3h. Now, minus. Remember that I have brought this down here. Now, minus f of x. What is our f of x? Please always use a bracket. X squared. Sometimes we want to do shortcuts and it messes up the whole process. Over our denominator is 8. I just enjoy math. Keep writing the limit as h approaches what? 0. Please. Let's keep writing the notations correctly. If I expand, I know some of you I'm boring you, but take note of the notations, please. Minus x squared plus 3x. Don't take shortcuts over h. Now, what do you notice? This would take out that. If that doesn't happen, then you've done something wrong. Your f of x would always be eliminated. All right, thank you guys. See someone from Gibson Pillay. See someone from Sudilek. School, lovely. Thanks for joining again this morning. Okay, just quickly, so right, so we continue again now. Now, what are we left with? I'm just going to get a fresh page. All right, just transfer this to a fresh page. It is important that you do the notations very well. This I've left now. The whole of this is gone. Okay, the whole of that is gone. I'm just going to up Beautiful. Now, what do we have left? Avoid shortcuts, guys. Limit as h approaches what? 0. We have write it out for clarity. Xh plus h squared minus 3h over h. And guys, bracket here. All of this should be in bracket. Now, h into bracket, x plus h. H. Okay. As h approaches 0, please put a bracket. It is 2x plus h minus 3. Now, there's an error that I've seen that learners substitute h as 0. Please do not substitute h as 0 because h is not yet equal to 0. H is approaching 0. Now, what do we have? We no longer have limits since we are now dealing with h approaching 0. Our answer is top notch. You get this 5 marks and you move quickly as possible. Please go and try this for me. F of x equals to x to the power negative 2 using first principle. Right? Go and try this. Everybody, you try that, write that down, try it, and make sure you're good. Hi, Busa Siwe from Southview, lovely. Those of you that are here as well, please, that have not yet responded, just let us catching us from this morning. And okay, guys, and this is it. This is your 5 marks. Let's move on quickly. We do not have time to play around this morning. Now, we're going to move to deriving by rules. Here, your algebra should be top notch. Your algebra should be on. Before I go into this, let's quickly write some algebraic simplifications that you should write. What simplifications that you are supposed to know very fast? Number 1, a plus or minus b. A over c plus or a squared minus b squared, difference of 2 squares, a plus b, a minus b. Number 3, a cube minus b cube. A lot of us have forgotten this from grade 10. Please follow what I'm going to do. I'm going to open 2 brackets quickly. Now, it is a cube minus b cube, difference of 2 cubes. It is a and b as my base. I'm going to drop it here, a and b. Don't forget this, a and b. Now, I'm going to keep the sign. It is a cube minus b cube. Keep my sign. So I'm going to put an arrow here and put a note for you. Keep the sign. Now, in the big bracket, what would I have? I'm going to take my a and square it. Right? I am going to get the product of a and b, ab. I'm going to square the last one, positive b. Take note, it is square of a, square the first, then product of, and square the last. The last one will always be positive because you're minus b times minus b. All right. Now, what happens here? Here, there's a negative here, it's definitely going to be a positive. Please understand that, and that will save you someday. All right, thank you from Defrak, lovely. Whitman from Southview, lovely. Bianca from Tongat, beautiful. Durban, great. Number 4, let's try the same one. A cube plus B cube, what will this be? We're going to do the same process again. All right, so you predict what I'm going to have in the first bracket. What am I going to have in the first bracket? I'm sure you've written yours so that you can mark with me. Write the first bracket. It is going to be A plus B. Okay, I'll give you 10 seconds to write your second bracket. 10 seconds to write your second bracket. Have you written your second bracket? 10 seconds to write your second bracket. 5 seconds more. Because I want to give you an attempt to try. First rule that I gave you. Okay, are you done? So what are we going to have? We square the first one, A squared. Product of the two, AB. Square the last. What happens to the sign? There's going to be a change of sign. Perfect, and you're done. There's no stories. Okay, we're moving to number 5. Using laws of exponent. Guys, when it comes to the laws of exponent, when we are deriving here, we never leave x. Okay, do not leave. Okay, let me go to the next page. I think it will be better. These notes will guide you before we even start, and you would see how fast we're going to be moving now. Number 5. Right, number 5. Do not leave x as a denominator. Let's see, at 6, we should be going to cubic functions. X as a denominator. What do I mean? Given that y equals to, just going to use both x to the power n. Please don't leave x as a denominator. This, the a, leave the constants the way they are. Some of us make mistakes and we take the a upwards. Don't. Just leave the a. All right. Ntwaki from Bethlehem, good to see you this morning. Lovely. Thanks for joining. Tabitha from Gauteng, thank you. All right. I remember the face, Tabitha. Lovely. Okay. So what do we have? Leave the constant. Only deal with the x. The x is positive at the denominator. It then goes up and becomes what? A negative. I have y equals to 1 over a x to the power negative n. Leave the constant. Only dealing with the x. It's a negative at the denominator. It goes up and positive. And you're done. Number 6. Change all radicals. Radicals, we can call them roots. Okay, and how do you change that? General rule. I'm going to say y equals to root of, I'm going to have x, I'm going to have a, I'm going to have b. This can therefore be written as x. You see, it is x to the power of b that we're dealing with. The a is the root. That comes as a denominator. You can see it. X to the power of b. That's what we have. The a outside, when it comes in, it becomes. Finally, number 7. Apply the laws. Apply the law of exponents. Okay. X to the power n times x to the power m will be x to the power n plus m, right? And if we are dividing with the same base, x to the power n over x to the power m would give us x to the power n minus m. Okay, now let's go derive quickly. We have a few questions to run through. Okay, Snaggle from Gauteng, JSS. Good morning. Hey, Zafira, how are you? Lovely to see you. All right, Tabang from Whistle Brom. Lovely. Love. All right, guys, let's run through about 6 questions, just deriving, and then we move to cubic functions as quick as possible this morning. It's a class on the run. Okay, look at the first one. First one is easy, 1.2.1. Okay, don't mind the way these things are written. It's supposed to be d y dx, capital Y, big there, like that. Okay, so number 1.2.1. That's very easy. If given that y, I'm writing this because I want to show you errors that we make as well. Please, I am now deriving. It's already been simplified. Simplify first before deriving, but this is fine. We remember how to derive? Given that y equals to ax to the power n, the y dx is a times 1. So we bring down the exponent multiplied by the coefficient, and then you subtract 1 from the exponent. Okay, what will this be? I know this is baby here. This is baby maths. 3x squared. 2 times negative 16 would give us, but the 3 was multiplying negative 1. Plus 3x, and then we subtract 1 from the 3 to give us 2. X squared, the 2 would multiply the negative 16 to give us 32, negative 32. We subtract 1 from there, leaves us with x. Is that okay? Plus 6x. There's a 1 here. 1 times 6 would give us positive 6. Subtract 1 from the exponent, which leaves us with no x. All right. Let me quickly write this here for you. If y equals to k, then dy dx equals to 0. Please, constant, you will get a 0. Okay. I hope that makes sense. 1, lovely. 1.2, something beautiful now. Some of us will be scared here, but just enjoy maths. 1.2.2. Given that f of x is equal to 4 over 5 x to the power negative 3 minus, there's quite a lot of work to do here, but enjoy the maths. If you apply everything I've mentioned so far, you will be fine. Okay, guys, you are not deriving yet, please. That's the emphasis. Hi, Abdullah, lovely. Kadira from Defaki, good morning. Good morning. Oh, Raisa from Ladysmith, good morning. How are you? Okay, so what do we have? We are not deriving. This is the notation errors that a lot of learners make. Simplifying. Never leave x as a denominator. Remember, leave the constant the way it is. So it's 4 over 5. My x is a negative exponent at the bottom. Take it up, it becomes x to the power 3. I hope that makes sense. Now, minus 3 over. Change all radicals. We are dealing with x to the power 2. The 3 is a root there, so it becomes a. Guys, never leave x as a denominator. So I am not going to derive yet. I am still dealing with f of x. Please take note. It is still f of x, not yet x prime. And don't derive one term, leaving the other. You derive at once. So I'm not deriving this. I would still leave it like that. Minus, all right? Now, what do we do? Do not leave x as a denominator. What do? We take it up. Up. A say to from Mpangeni High. Good morning. Lovely. Good to see you. Now, what do we have? 3. Your x now goes up. It's a positive. It becomes a negative. Lovely. Guys, please take note. I am not deriving yet. I simplified all through. That is why my notation remained as f of x. Now it's time to derive because I am done simplifying. What is therefore my f prime of x? Now I can do my derivative rules. Take the 3, all right? Use the 3 to multiply the coefficient so that you would see what I'm doing. It is 3 times 4 over 5, all right? Now we subtract 1 from the exponent to give us 2. Negative 2 over 3 is the other one. So it's negative 3 times negative 2 over 3 x to the power. Please use a calculator. Some of us don't use calculators. Avoid shortcuts. Use a calculator here. Negative 2 over 3 minus 1 will then give us what? Negative 5 over 3. Please, your calculator. Just use a calculator so that you don't negative 2 over 3. You are subtracting 1. It's a term you don't want to make mistakes. Now, what do? We simplify. F prime of x. And some of you don't write this. You just say equals to. That is completely wrong. And not just write equals to. You need to tell us what that line is equal to. So x. Now, 3 times 4 would give 12 over 5 x squared. Negative times negative would, this 3 would divide that 3. Okay, I'm going to leave that there. But that 3 divides that 3, and that gives me what? 2. X to the power negative 5 are safe to leave your answer like that. Except the examiner tells you to write it as positive exponents. But if they don't, you are okay just leaving your. Okay, so if they want positive exponents, you don't have to do this except for this. If this instruction, then f prime of x would be equal, because I've seen a few questions where the examiner wants to test if you know your exponent. It becomes 2 over, it's only the x that you are moving. It was negative up there. When it goes down, it becomes what? Positive. Enjoyed that session, and take note of the errors that we are highlighting this morning. Let's run through a few more. Okay, got a few nice ones more. Ooh, beautiful here. Beautiful. I'm in dy dx 8.2.1 given, guys, simplify before deriving. Simplify before deriving. Please, always. Now, what is this telling us? Y, therefore, is equal to x squared, 1 over x squared. All right, I'm sure we all know how to FOIL. We take the first and multiply with the first. That would give us what? X to the power 4. Then we multiply the product. Okay, so it is first product of the two terms, multiply by 2, then square the last. That's just. Now, if I multiply x squared, check this. X squared times 1 over x squared. That will divide and give me 1. Then I multiplied that by what? By negative there. Is that okay? So it's negative there. And that gives me what? Negative 2. That comes in there. Then I'm going to deal with the last one. Negative times negative, positive. 1 over x to the power 4. Guys, this is why. Do not leave x as a denominator. X to the power 4 minus plus x to the power negative 4. Only now can I derive. There's a mark for all of this simplification. Now let's derive. Dy dx equals to the 4 multiplies Subtract 1, lovely. Minus 2 is a constant. When we derive a constant, it is 0, so that goes away. Negative 4 times positive becomes what? Negative 4x. Please be careful here. It is negative 4 we are dealing with. Negative 4 minus 1 would give you negative 5. Out of pressure, you would find learners writing 3. It is negative 4 we are dealing with. Right. Ibzavumani, good morning, good morning. All right. Princess Lepoto, okay. Lovely to see you. Lovely to see you. Guys, are we, is it making sense to us so far? Just learning simple errors that we make. Oof, time runs so fast. It's a 1-hour session. Maybe we'll make it 1.5 hours. I'm enjoying myself this early. Right, 8.2.2. Questions if you have. All right. Now, dx, please. This is very x to the power 3 minus 1. This is different. Can be written as 3. Now, please do not write this in this particular one. You are only allowed to write equals to once. Take note. The equal sign should appear once. I'm not going to write any equal to. I'm just going to. I taught you how to simplify that. We're going to open a bracket. Okay. Let me do this. Open a bracket. This is over x minus 1. We open two brackets. X minus 1. All right, because the minus in the original. So what do? Square the first one, x squared. The product of the two, x and 1, would give me what? X. Square the last one, always positive. But in front of the x, the sign must change. If it's a negative in the first bracket, it must be positive in the second bracket. And this, then divide. Guys, what I have left is dx, x squared plus x plus 1. Do you notice I have not written an equal sign? Now that I'm done simplifying, I am going to write an equal sign and write equals to. Please don't write the x equals to. You just jump to equals to. Now we derive. What do we have? 2x. Remember, we subtract 1. Take note of the notations. Hi, Bianca from Tepuyarina. Good morning. Lovely. I hope you're learning and we're getting some. Okay, guys, I am running to the next. If you need the slide, just send us a message. We'll be able to send. Okay, or will make sure you can. Let's just run very quickly with this one. So I'm going to be very fast, 2-3 minutes on each of them. Okay, what do we do here? We are going to a plus b over c. X squared plus, can I quickly deal with that? X to the power 1, all right? But the 4 outside comes in and becomes x to the over x squared. Beautiful. Keeping my dx. Let's simplify. X squared and the x squared will divide each other. I have negative 2, loss of x, plus x to the power. Let me write the process out. When we divide. Okay, 1 over 4 minus 2. So what do we have? dx. Guys, I am not deriving yet. Remember, I am still simply, right. 1 over 4 minus 2 would give us negative 7 over 4. Please use calculator, please. A calculator. 1 over 4 minus 2. Please, negative 7 over 4. use a calculator. Now let's derive. I'm going to throw in my equals to. The first one is a constant that gives us 0. Now, positive 7 over 4 times 1, x. What are we doing now? We are going to subtract 1 from negative 7 over 4. Negative 7 over 4, all right, minus 1, which is minus 4 over 4. Hi, Kuvadia from LMS. Good morning. Good morning, guys. Sipo from Bensel College in Johannesburg. Good morning as well. In case I missed you along the way, I didn't say good morning. Good morning. Good morning. Love to hear from everyone who's watching, guys. And that is it. Let's run here quickly. What do we have? X squared. Let's take the x up. 2 and derive equals to x negative 1 times negative 2 x, and then we subtract 1 from the exponent, negative 2. Get your 1 mark there, 1 mark there. Here you would have gotten a mark. You would get, for simplifying, okay, that's not right. You'd get a mark there, you'd get a mark there, and you are likely to get a mark there for simplifying that. 3 marks. Please take note of your notations. I cannot overemphasize the marks we lose because of wrong notation. Right, I think, could that be the last one? Oh no, I still have so much. Okay, let's see this one quickly. I prefer quality, all right? Let's see this. This looks yummy. Ooh. Head. This looks so yummy. Right? Don't multiply. Let me write out the question so that you can x into bracket cube x minus 5x. All right. Let us change first into exponents before we solve. X to the power 1 over 2. Remember, if we don't write anything on the root, it means squared. It's 2 outside. What happens? When it comes in, it becomes a denominator. What will this become? X to the power 1 over 3 minus 5x. Don't let math scare you, guys. I am not deriving yet. It is y. Now, what do? We expand using the law of exponent. What do we do when we are multiplying with the same base? We add. I'm just going to write this form. Add 1 over 2 plus 1 over 3 minus 5x to the power 1 plus 1 over 2. Add the exponent. Guys, it is still y. Use your calculator. 1 over 2 plus 1 over 3 would be 5 over 6 exponent minus 5x. 1 plus half would give us what? 3 over 2. Can we derive? Check. I'm only writing this thing once, and I'm writing it at the end. Have 5 over 6 that comes down. X. We subtract 1. 5 over 6 minus 1 will give us negative 1 over 6. Use minus. Now, the 5 would multiply the 3 over 2, right? Now you know the rule. If you use your calculator, 5 times 3 over 2 would give us x. Now, 3 over 2 minus 1, that will give us a half. And are done with that. Check how errors must be taken. Errors must be taken care of. Let's look at this one. Determine the derivative x. Okay, we have to expand first. F of x is equal to x minus 1 over x, so that it's clear. Okay, what do? Change before you expand. This is x to the power 1 over 2 minus 1 over x. All what? But the rule, guys, it is still f of x. Right, square the first one. 2 times 2 would give you. Okay, please remember laws of exponent. X to the power half, all right, times 2. That. And that will give us what? X. Let's have. Now, what do? We multiply the 2. Let me do x to the power half times 1 over x. But let's multiply that by 2. We said you multiply the product by 2. Okay, I see 2 times x to the power half over x to the power 1. Laws of exponent. What do? We subtract. Hi, Vukosi from Southview. Good morning. Okay, half minus 1. Remember, this gives us 4 minus 1. And that gives us what? Negative half. So it is, and it's a minus 4x to the power. Now we can square the last one. Plus 1 over x squared. Okay, beautiful. 4x minus 4x to the power negative half. We are not going to leave that as a denominator. So what do we now do? Can we derive? Absolutely. Oh, what do we have? That's a 4 there. Are we together? That is a 4. Okay. How do we derive the next term? Derive the next term together. The negative multiplies the negative automatically. 4 times half. Use your calculator. Would give x. Negative half minus 1. We always subtract 1 from exponent. Negative 3 over 2. Negative times positive would give me what? A negative. 5 marks. 5 good marks for you. Be careful. Use your calculator to do every little step. This is an exam, final exam. You don't want to make mistakes. Thank you for all the likes. Thank you for all the likes. Thank you for all the love. All right. Please, I hope this makes sense, especially with simple algebra. It's a very important part of. Hey, beautiful. You can take screenshots solutions so that you walk through again. All right, walk through again, take screenshots, then you can deal with. Let me see what I have next. And after this, time. I was supposed to look at cubic functions, but it's okay. All right, let's see. Let's see. 7.2.1. Y, let's expand. 2x squared plus x. Therefore, dy dx to be equal to x plus 1. We're done there. 2 marks. 7.2.2. I kind of like 7.2.2. I love it. I love it. I love it. 7.2.2. Let's see what 7.2.2 would look like. It says, please check. Find the y dx. It means differentiate y with respect to x. If the square root of y plus x equals to x plus 3. Guys, we cannot find the y dx until you find what y is. The instruction says differentiate y with respect to x. So you need to find what y is first before we differentiate. So what do? Let's square both sides to get rid of the square root. Our knowledge of surds. Y plus x would be x squared plus, remember, multiply 3 times x, but multiply by 2 and square the last one. So if I then move my x over, it subtracts from the 6 plus 5x. plus 9. Now we can find dy dx to give us 2x squared plus 5. Beautiful. Cannot derive, guys, and the examiner will give you the p, the q, dy, dA, anything. If they say dy, dA, you leave every other thing and derive with respect to just the a. All right. I hope this makes sense. We've got one more. One more on this. I just like to look at a lot of examples. Now, this notation, 7.2.3, still means you should derive. Same thing, like your dx. So what do we have? Okay, let me write out the question for clarity. Oops. Lovely, lovely. I'm seeing something beautiful. X. Let's see what to do here. 4 over x plus. I'm going to take this one easy. The x is underneath the root with the 3. Take note. The x is underneath the root. This we can split by saying times root x over x. Please take note. The square root is housing both the 3 and the x. Using laws of exponent or roots, can split that, but each of them must have a root covering them. Okay. X, we still have 4 over x. Okay, write my x. Now, plus what? Root multiplied by x to the power half over x. All right. X, 4 over x plus root 3. We can now use our laws of exponents. Half minus, this is to the power 1. We subtract x to the power negative half. Only now we can derive after simplification. Now remember, when I'm now deriving, that's where my only equal sign. No. Before I should have done. Why do I keep right? I should have taken this up. Negative 1. Okay, so that I have less lines. Lovely. Now, can I derive? Negative 1 times 4 would give me x. We subtract 1, negative 2. Now, positive times negative will give us x. We subtract 1, negative 3. Guys, please quickly, in the next 5 seconds, can I get your thumbs up if you are okay with what we've done so far this morning? But are you okay with what? Learn something? Did you learn? I'd love to read from you. Drop me a comment quickly. Errors. Errors, quickly. Bang, lovely, lovely. All right, quickly, I've got 10 minutes, but in that 10 minutes, I want to give you something very important. Okay, great, thank you, Kuvadia, thank you, Zafira, lovely, Sian. That I love to hear from you. What is saying, so isn't just 2x plus 5x power 2 plus 5. Which one is that? Let me go look for it. An error in the presentation. Let me see. Oh, yeah, sorry. This is 2x plus 5. Thank you, Nafia. Thank you for x plus 5. Remember, we subtract 1 from that keen observation. See, I also made the error there. Okay, guys, few minutes, cubic functions. I'm just going to give you something here. Cube. Remember, this is calculus part 1. I want you to get the marks. Guys, if you can get marks in calculus and your algebra, you are sitting on 100 marks. Right. I'm just going to quickly do something here. The big 5 of calculus, and I'll end the session today. The next session, we would look at the whole of calculus in terms of cubic function and applications. All right. What do I mean when I say the of calculus? If you know this big 5, you are on your way to something good. The first one is to understand. Okay, let's move anti-clockwise. What is the rule of the turn? Call it the minimum. We could a stationary point. F prime of x must be equal to 0. That's number 1. Number 2. Whenever you see the word tangent, right? Thank you, Cyan. Calculus now easy. Beautiful. Whenever you see the word tangent, F prime, okay, let me. I equals to what? Mx plus c. F prime of x would be equal to that m, the gradient. That's number 3. Number 3 is called the point of inflection. Or the point of inflection. There's a few things here, so let me quickly erase this. Of inflection. Right. It is the point where concavity changes. 1, it is the point of maximum or minimum gradient. A point of maximum or minimum gradient. How do we find that? We say f double prime of x is equal to 0, or we say x will be equal to x turning point 1 plus x turning point 2, the midpoint of the point of your turning point. It is the midpoint. All right. You would get the schedule. Okay. I think the next one, next maths class would be probably on Monday because it's physics. Next math session would be, well, I think it's on Monday. All right. Just follow the schedule that we sent through, but we're going to deal with paper 2. We are trying to blend both paper 1 and 2 at the same time. Okay. Now let's look at point number 4. Cave up. Cave up. F double prime of x is equal to, okay, we're saying the point where the gradient, right, is per x value. Please, this is very important, not just increasing, it's increasing per x value. And finally, number 5, concave down. The next session, I'm going to start from here and draw a cubic function for you. Concave up, sorry, not equal to 0. greater than 0, concave up. All right. There. Now, concave down, f prime prime of x is less than 0. We're saying the gradient decreases as x value. Okay, I'm going to change something there. As x value. I cannot overemphasize the importance of this, the big five of calculus. Get this big five, understand how it works, and you are good to go. Very, very important. The big five. Okay, we're not in the zoo, but it's big five. You do this and you can roar at any question. Okay, you become the top of, the zookeeper now when it comes to calculus. All the big five listen to you using this. But guys, because of our time, the day is starting. I'm just going to show you things that you should be able to do. Okay, we're going to run through a few questions. I had these questions thinking I was going to be able to and try to deal with them before the next session. I only have 3 minutes to give you some other vital information. Can take screenshots. All right, take screenshots and walk through. Here is the second one. Go through as well. Just practice, 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 practice. I have this one as well. Beautiful here. Lovely. 17 marks question there. Guys, imagine the first question, question 8, you're sitting on 12 marks, you get all the 12. The second one, you're trying to get all the 17 based on cubic functions. Get all of those. We need to get all of those. All right. All right, guys. Please go to our YouTube page and look for these questions. They will help you understand more of calculus. I have 3 pictures to show you, so don't out. May, June 2022 questionnaire. Just type crazy physics and type cubic functions. You would here I was dealing with one of the questions on cubic functions of May, June 2022. Get your hand on the paper, answer the question, and mark watching the video. Right? That is one. Ooh, I cannot overemphasize this one. This is important. Learn the relationship between cubic function, parabola, and straight line. How cubic function changes. There's calculus relationship between a and its derivative. Please make sure you watch this. Finally, I think I've got 3. Yes, applications of calculus. We're still going to do this, but because of time limitation, run through. But you take your time, go through these 3 videos on and you will be fine. All right, this is Crazy Physics signing out saying thank you for watching and thank you for logging in today. All right. Via YouTube, via Facebook, Instagram, just look for Crazy Physics. Or you do send us a WhatsApp message, 744-2103. Friday, tomorrow, we're looking at physics, vertical parallel. And on Monday, which is the 16th, we're looking at like that, keep alternating. All right, this is Crazy Physics, Bishop signing out and saying once again, thank you for watching. Please share the video. Thank you for all the likes. Thank you for all the likes. Thank you. And do have yourself a very, very great day. Please make sure you quality rest in this. Right, guys, this is a signing out and goodbye. The video would be available for you to watch again enjoy the videos. Some comments. Thank you for all the likes and good. Thank you, Kelly Gora. Thank you, Zafira. Thank you, San. Thank you, TM47. Thank you as well. Hi, everybody.